So how do we see light? Well, we've got these amazing organs. We've got two of them actually. They're called eyes. So basically the way that we see light is that light travels, here's a few rays of light, travels through our cornea, this transparent layer here. It travels through something called the aqueous humor. So there's this liquid here in our eyes. The light keeps traveling through. It travels through our pupil. So our pupil, this little spot here is the black part of your eye. It's actually, it's actually space. So for the light to travel through, it looks black because the back of your eye is black. Your pupils sometimes look red when a flash of light flashes into your eye and it bounces off the back of your eye, which looks all red and bloody, and then bounces back into a camera. But normally, pupils can look black. It's surrounded by an iris. The iris of my eye is blue. So the iris controls how much light goes through the pupil. So if it's really, really dark, then your iris allows lots of light through. And if it's really, really light, then your iris contracts so that not much light gets through. So it controls kind of how much light gets into your eye, just so you can kind of see perfectly the whole time. The light continues, so it's traveled through the cornea, travels through this aqueous humor, this liquid here, travels through the pupil. It then hits a lens. So a lens is something which focuses light, controls, bends light into a particular point. So we have a lens that's really important to enable us to see clearly. Light travels through this lens, and in fact, when light travels through our lens, this is a biconvex lens. The light focuses, it travels through this vitreous humor, this other liquid. The light focuses, so the light rays all converge. It's a biconvex, so it's a converging lens. All those rays of light converge on the back of the eye. So this is called this whole thing at the back here is called the retina of the eye. But it converges ideally on a point called the fovea, and this is what enables us to see kind of really, really clear vision. At the back of the eye, we've got a range of, in the retina, we've got a range of light-detecting cells, light-detecting receptors. They all pick up this electromagnetic radiation, so light from the environment comes into the eye, is focused on the retina, and then in fact travels through, this is called the optic nerve. It travels through the optic nerve. All that light travels, or the messages are then transmitted through the optic nerve to the brain, and the brain goes, I can see stuff. Isn't that awesome? Unfortunately, sometimes our eyes don't work just as well as we'd like them to. So sometimes, or some people have a condition called hyperopia, which is long-sightedness, and the lens can't do quite a good enough job of focusing light. So what happens is, instead of focusing it on the retina here, it focuses the light a little bit past the retina, and so people see it's kind of blurry. So that they need glasses or they need prescription lenses. And the simple fix is, what people do is they get glasses or contact lenses. And here's an example of a second lens. So you have a lens in the eye, it's not working great. You chuck another lens in the front, and that just helps the eye to focus the light, and it does it just the right amount so that the light then does focus just right on the back of the eye and the retina. And that person who's got long-sightedness, once they're wearing glasses or contact lenses, they can then see sharply or clearly again, and it's not out of focus. Of course, some other people have something called myopia, and I actually have myopia, which is short-sightedness. And again, the lens just can't do quite a good enough job to focus light right. So in fact, it focuses light here instead of on the back of the retina. So the image on the back of the retina is a little bit blurry. So of course, what these people do is they get a lens. So this is a biconcave lens. This shoots the light, diverges the light a little bit more, and then that enables the person's lens to do its job and focus the light right at the back of the eye there on the retina, so that the person who's got short-sightedness, their vision has been corrected. So that's all about the eye. Light travels through the cornea, through the pupil, that black bit, and then focuses through the lens, really importantly, which focuses the light on the back of the eye on the retina. And of course, we can correct vision, whether that's long-sightedness or hyperopia, or short-sightedness or myopia, by using more lenses, glasses or contact lenses. So that's about the human eye, and it's also about how light interacts with lenses in the real world.